In this video, we're going to take the parts that are sitting in that room after they've been pushed over from the schematic, and we're going to place them on the layout as we would like them to be placed on the printed circuit board. And one of the important features that we're going to take advantage of to make this so much easier is the cross-select mode. Make sure that is highlighted under Tools. I've set up my screens so that I have the schematic on one side and I have the layout or the printed circuit board dock on the other side. Now that little room that has all of our parts is sitting way over here on the right hand side. To make it a little bit easier, I'm just going to take all those parts and move them to the top of the board so that I can see them more easily. So I click once in that room, it's highlighted now, and now I can click and drag that whole room, and we're going to just place it over here on top of the layout screen. When we are looking in the layout screen, we have all the parts labeled with their reference designator and their footprint. And they're all sitting up here with these little ghost wires that indicate the connectivity. The first step is to move all the parts over to the outline of the circuit board in the way we want them to appear on the board. And this is, again, another example of where that block diagram that we created right at the very beginning of this project and carried throughout the design process is so important. Because that block diagram kind of gives us a little bit of association information. We would like our layout to look kind of like that block diagram. We're going to have the power conditioning circuitry. We're going to, in one region, we're going to have the timer circuitry with those parts associated in another region, and we're going to have the LEDs in another region. And so we can literally use that block diagram to help us identify the parts and how we move them over to the board. Now, generally, some parts are going to have special locations. For example, the connector, we obviously want that the power jack, obviously we're going to want that toward the edge of the board. That's going to be really important. And likewise, the indicator lights for the power, we want that closely associated with the power jack. The test points, we're going to want that closely associated with the power jack. The decoupling capacitor for the 555, we're going to want that closely associated. And so being able to reference the schematic to help us identify specific parts and then move them to the circuit board is going to be really important. And here's how we take advantage of that. Remember, under Tools, we want to make sure that we have cross-select mode so that it's highlighted. And there you see the little square around the icon that says it's highlighted. If we click on it, it toggles that feature off, and we come down again, it's not highlighted anymore. So you want to make sure we toggle that on so that when we come down, it's highlighted. The reason that's so valuable is when I click on a part in my schematic, I will see that part in the little room with all those parts. For example, let's grab the power jack because we're going to move that over to the upper left corner of the board. We'll highlight it in the schematic. And look, over here it's highlighted in the printed circuit board. And so I can now drag that over to my board, and I want to put it over here, but you know what? I really want to rotate that. While my cursor is highlighting that part and I'm able to move it around, in the same way in the schematic, when we push the space bar, rotate it, we'll do the same thing. And here we are. And so I can keep rotating it, and here we are. And so I'm going to move that over to the upper left corner. Now, you'll also notice that when I place a part and when I do the routing, it's all about the grid that I'm using. If I can, I'd like to use a grid of 20 mils as kind of the coarsest grid. That's going to be a good placement grid, a good routing grid. And so how do I change the grid? I can always identify what the actual grid is by moving down to the bottom lower left of the screen. Just be careful that there are two screens up and there are two grids. One grid is the schematic, which is 100 mils, and the other grid, when I'm on the layout, right now it's set for 5 mils. So when I'm on the layout screen, if I click G, this brings up my grid for the layout, and I'm going to select 20 mils, and now it's changed. I haven't changed the grid for the schematic, and I don't really care about that now because I'm not going to use it. So I have a 20 mil grid for the layout. And I'm going to move that part up to the upper left corner, and we're going to zoom in and kind of get that a little bit better. And again, What's important is we got the keep out region here. We want to stay outside that keep out region. So what's the next component? Well, generally, it's nice to put decoupling capacitors or filter capacitors in close proximity of where they're filtering. So let's put one near the input. So we've got our filter capacitor. Let's highlight it. And here it is on the layout. So here's our capacitor. We're going to grab him, and I'm going to rotate him around a little bit. Now, it's not necessary to worry about the routing of the ground, because we're going to have a plane on the bottom layer for that. And I don't want that part too close to the connector, because after all, I'm going to assemble this by hand, and I shouldn't necessarily put the connector down first, but if I do, if I put the capacitor too close, it may be a little hard to get the capacitor down and do the soldering. Next, I've got my test point. Where's that test point? So I'm going to highlight it in the schematic. Here's my test point. Bring it down. And for the test point, this is where I'm going to stick the 10x probe. I don't want it too close to the connector, otherwise it'll be hard to get the 10x probe. We're going to put it over here, but I'm going to rotate it so that it goes lengthwise. And personal preference doesn't really matter, but I like having the ground of the 10x probe toward the outside of the board. It just makes it easier to remember. You'll notice on the 10x probe, in the footprint, we have a little ground symbol, which is great. That's going to remind me, oh yeah, the 10x probe has the signal on this side, the ground is going to be on the outside direction. And that way, when I'm probing the board, I don't have to think too hard. It's one less risk site to worry about. I always know, ground is to the outside, signal's on the inside. Let's see. We've got our LED. And where is that LED? This is going to be the indicator light. There's the LED indicator. We're going to grab him, bring him over here. And again, it'd be nice to kind of show the orientation. So I'm going to rotate this guy. And I need the resistor associated with him. And where's that resistor? It's over here. Bring him in close proximity. And this is where thinking about the connectivity is going to be important. So you'll notice the R and the diode orientation. I really want to reverse the direction of the diode. And that way, if I reverse the direction of the resistor, hey, now I've got the connections between the diode and the resistor closely spaced. Now, again, my strong point is not neatness. And while it's not essential for the functionality, a neat board, number one, it looks nice, and number two, it sometimes is easier to debug. And so I'd like to align these two guys. I could use a coarser grid, or I could take advantage of some of the editing features built into the tool. I'm going to highlight these two. I want them to align their centers. And so I come over to Edit, and Edit Align, and let's see, how do I want to align them? And so we can align the bottoms, and there we go. And now I'm going to move them up. We select both. I'm going to grab them and move them up a little bit. And then finally, what's left? I think I've gotten everybody that's part of the power conditioning. Just to make sure, I'm going to highlight each one in the schematic using Shift and click. And so I've gotten all of these guys. And let's see. Hey, you know what? I've identified them all over here. I don't have any more in the room. And so now I've got a good indication that I've got all the parts for power conditioning. Now we'll do the timer. Let's grab the 555 timer first and get that settled. Here he is. I'm going to grab him over here. I'm going to rotate. The little yellow dot tells me where the center pin is. It tells me where pin 1 is. Let's see, where's a good spot for him? We're going to be able to move him around a little bit. We'll put him right over here. After we put the IC down and we have a good orientation, the next thing we want to place is its decoupling capacitor. So we're going to come and grab our decoupling capacitor, and there it is. Now, if I had clicked on the part, but clicked on the other side of that part, I'm really not clicking on the part, I'm clicking on the terminal on that side, and you can see only one terminal is selected. And so you want to be a little careful when you select the parts that you click on the part itself. And now I've got the part, which means all of its terminals. This is the decoupling capacitor, and I want to place it. Here is the power pin connected to pin 8. I want to place that in close proximity to where the component itself is. That's the first step, placing the part, the IC, and then placing its decoupling capacitor in close proximity. We've got the switch coming in. See, where is that switch? Here is the switch. We're going to place the switch over here, and that's also going to be in close proximity. And let's see the orientation for that switch. So I've got the power on the top, and we can see the wire connectivity to it, power on the top, and so this is a natural flow for the power flow. So there's going to be the switch. You want to be thinking about the end use of the board. These are going to be physical structures. I'm going to have a switch. I'm going to want to be able to move the flag in and out of this component and be able to solder it onto the board easily. Let's see, what else do we need? Oh, we need the timing circuit, and that's going to be over on this side. So I'm going to highlight the top resistor. That's this resistor here. I'm going to drag him in, and again, I'm going to rotate him vertically because I want him to appear kind of as the circuit is. So here's going to be one of the timing resistors. I'm going to grab the next timing resistor. That's this one. Again, I'm going to rotate him, and I want to make sure that I get the orientation correct. And now I see, oh gosh, you know what? I need to rotate this resistor. There we go. Got the timing for him in good shape. And then finally, I need the capacitor. Let's see where he is. So I highlight, and again, it's important to be sure that we highlight the whole part. You can see I only highlighted one of the pins for the capacitor. I go back, highlight the whole part. There he is. And this again is the timing capacitor. And we're going to rotate him again so that we have a nice flow for those parts. And again, what we can do is select those three. I think they're pretty well aligned, but you know what? It'd be nice to align them vertically and also to space them evenly. It just is a little bit more pleasing to the eye. It has nothing at all to do with the functionality. So we're going to align to the right, but more importantly, we want to distribute vertically. And this will help us distribute vertically. And keeping them to the edge is perfectly fine. So if this one were farther away, for example, we select the three of those, we come over here to align, and we say, okay, align, now we're going to distribute evenly. And there they are. Now I'm going to tighten these up a little bit. Again, we can do that automatically. Align. And let's see, I want to decrease the vertical spacing. And that's going to decrease the vertical spacing based on the grids. Let's do that again. Decrease vertical spacing. And we'll do one more click. Again, this is purely personal preference. We want to keep them far enough apart so we can assemble them easily, but close enough so they don't take up that we can solder them together. Okay, let's see, what else do we have? We've got the switch. We're going to do ground. Oh, we have a test point. Let's grab our test point. It's over here, and we move it in. And again, I like the test point with the ground toward the outside edge. Just makes it easier to identify. Exactly where we put this isn't real critical, but I want to have a little bit of association with, okay, this is going to be the output signal of the 555, so we'll put him over here. And then we're done. We've got all of the parts associated with the timer circuit. And lastly, we have the LED diodes. These are going to be distributed over to the right side of the screen. Let's move the switch over first. Where's that? Here's that switch. And again, form follows function. So this switch is going to isolate the left from the right. So let's rotate him so that it shows a little bit of the order. Now, to get precise alignment and make it look neat, we're on a 20 mil routing grid. If we were to move to a 5 mil grid, then we can get the parts aligned a little bit better. So if we push G and we go to 5 mil, That gives us a little bit finer control in aligning the parts. Okay, and now we're ready to start moving the LEDs over. Let's move all 4 of the LEDs over. So I'm going to click and highlight the first one, shift, the next, the next, and the next. Now D2, it looks like I didn't quite touch the whole part for D2. So let's come back and try to grab him. There he is. I've got these 4. Now I'm going to move them over to the right-hand side of the board. Okay, and again, it's all about thinking about how this is going to be used. We're going to have different resistor values for these LEDs. We want them far enough apart so we can distinguish their relative brightness. Now, in the same way that we used we selected multiple parts, let's also come along and select the resistors. So here are our 4 resistors. Again, we're going to drag them, bring them over, and here's where we're going to have to rotate them a little bit. Let's see, let's take the first one, we highlight it, we're ready to move it, we rotate it, and there we go. The next one, we highlight him, and he's connected over to this guy. Now we see we have to rotate each of the diodes. Now I'm going to space these diodes apart a little bit. Let's get the resistors aligned. There's one. So we've got the resistors, we've got the diodes. Let's adjust these guys so that they're all horizontally aligned and spaced apart. So we come over to align. Let's see, first let's align their bottoms. Now let's space them horizontally. And that's a good spacing. And let's do the same thing for the resistors. Now again, purely aesthetic, I've got the switch over here that turns them on. You know, let's kind of make it aligned. So I'm going to grab all of these, I'm going to bring them down, and now we can see, there's a kind of a pattern to what we're doing. That we're going to turn these on and we're going to turn each of these on. We've got the resistors over here. And there's one last component I need to move over, and that is the test point. And where is the test point? He's hiding over here. So we're going to bring him over, and again, this is going to be aligned with, I want the ground on the outside edge. And where is a good place to put him? Well, you know what? I think I'm going to put him over here on this side. Exactly where isn't going to be too important because, we'll do routing for him. So we'll just keep in mind that he's going to be connected to this pin over here. And we're done. Now, we don't need the room anymore, and so I can come over here and I can delete the room. So we highlight the room, we say delete, and it's gone. And we're done. We've placed all the parts. They look pretty neat. I've got the part associations as I want them, and now we're ready to add the ground plane and start some routing.